What up guys, continuing on from where we left off in the previous video, we're going to be learning about the concept of lemmatization. So lemmatization is another technique when it comes to normalization. I talked about that. Normalization is the very brute force technique of changing or maybe normalizing your entire sentence to what it actually means in the root. Now that we saw about stemming in the previous one, we saw in particular about the Porter stemmer, which is another algorithm that works well for stemming, but it's also very brute, right? There is no tense that is calculated or tense that is caught in that. So with advanced stemming, or maybe I would say that the lemmatization techniques, we get something called lemma, which is nothing but the base form of inflectional forms. So the inflectional here means that it is going to hold forth the past tense, future tense, present tense. It's also going to hold for the actual meaning of that word, and then try to attach it to the and try to do the normalization work. And we're going to be seeing about that as part of this one. And if you can see that the process of stemming or process of the advanced stemming, which is that intelligent stemming technique, could not have come forth in just one day or 2 days. There's a multiple way of saying things. We as a human being have evolved. We have said things differently from what we have told 10 years ago, and we have advanced to this stage. And there's also a little bit of sarcasm to it. There is a very different tone when it comes to it, and there's also a different way of saying things when you're angry, when you're sad. The same word or the same sentence can mean different things in terms of the mood with which you're saying, or probably in terms of the tone with which you're saying. So when you're trying to normalize that, we are trying to be a bit more advanced and intelligent about it, and that's what the lemmatization technique does. So if you see that, we're going to be doing a little bit of a code example to actually talk more about it, and I'll just directly jump into my PyCharm to show how exactly that works. All right, so we talked about the Porter stemmer in the previous video, and we're going to be continuing with the same sentence, and so that I can show you guys the difference between that. And if you see that with respect to the lemmatization technique, the very important word, or very important, I would say, the concept is that it is not going to be just a simple brute force stemming. It is going to be using the word net, which is the NLTK database, which I told, which we're going to be seeing more about it in the next video. So just assume that this is actually the lexical database which has multiple relations. Let's say that there is a word like probably jumping. Now the jumping can go with multiple words. I can say jump in a very sarcastic tone. If I put it in that relation, I can say jump in a very sad tone. I jumped to this conclusion. I can say that I was very happy, so I was jumping up and down. If you can understand that, right? So it's different way of saying things, but where you put that word is very important. So when we are trying to do that, it's called as lexical analysis, and the lexical database is called as WordNet. It has close to millions of lexical relationships available for just the English language alone. Similarly, there are multiple languages, and it has the entire database of lexical scopes and matches, and we're going to be using that for this video to see exactly how the lemmas are going to work. So let's get this thing started. We used the Porter stemmer in the previous video, and I showed about how this exactly works. And in this video, we're going to be doing is that we're going to use the NLTK again, and we're going to use the stem again, but instead of the Porter stemmer, we're going to be using the word net lemmatizer. So lemmatizer is nothing but, again, I told you, is a intelligent one. Now we can just going to be going through the same process of creating an object, which is just did here, but instead of stem, we're going to be calling the word lemmatize. Now lemmatize cannot happen without the token. So if you do just the lemmatize word, and you can see for ourselves how good it holds for. Now you can use the same sentence. I hope you can see the difference between that and here. So let's run it. It does take some time because it's doing the comparison internally, and now let's go and see how it works. Now brilliantly, it is not converting wrote to write. It says that I wrote a book when I was 5 years old. It's still not considering 5 years as 5 years, and I still am writing a book at 24. So it's still holding that sentence. And now it says that, does this writing process continue into my future? It should be a question mark here. Let's say I'm going to question mark. I will have to wait and see. So exactly what I expected. Now if you see here, the continue does not have the continue without an e. And if you want to understand much more in detail, the writing is still writing, it's not right, and the road is still road, it's not right. So what it does is that it's doing a bit more kind of an lexical analysis to give me a better sentence, or I would say better token, which is going to be useful for my algorithm. It is still holding my analogy, it is still holding my entity, it is still holding my actors, it is still holding the tone with which I say it. And that's very very important part of doing any kind of normalization. So does it stop here? Once I have the lemmatized word, can I just go forward and create anything I want to create? Is this foolproof? Does it work all the time? It may not work, but what happens is that as you are growing this NLTK data, or as you are growing this database of lexical scopes, you will be in a point where everything that you're colloquially speaking can be easily parsed and given a proper lemma at the end of the day. So it might not be available if you feel that okay, this is not what I'm trying to say, this tone is a little bit out of context, and you want to create a different lemma. You can you can even create your own kind of a lexical scope and contribute to the data net, which is obviously open source. So let's now change the sentence a little bit so that I can show you guys how exactly it can work. Now I'm going to be doing is that I'm going to removing this, and I'm gonna do the sentence that I just said. I'm gonna say I should not have jumped to this conclusion. I was jumping up and down in joy. Now let's see how this gets lemmatized. I'm pretty much, yeah, it's not breaking anything, it's not doing anything, and it's just sticking to the scope. Now you might get confused as to maybe what exactly does it do. Does it just convert my present tense to past, or past tense to present, and does do just that? No, it does not. It is stemming the word. The stemmed word or the lemmatized word need not make sense to you when as you are writing it, but it will make sense to the computer in terms of, yes, this is the root of the word, and it is going to be sticking to the crux of the sentence. It is holding for that. It might not be colloquially how you are writing it, but it might be the way that the root is sticking. That there is no change in the root of that word. The root is going to be still there. Even if you change multiple, even if you grow trees on top of that root, the root is still the word's root. So that's the whole idea behind the process of stemming and advanced stemming, and that's what I showed you guys as part of this one. So you will not call this a stemming technique, rather you call this a lemmatizing technique, because it's an advanced, or it is an intelligent stemming process. So that's what I wanted to show you guys as part of this video. Probably that's the end for this one. Let me meet you in the next one, where we're going to be talking more in depth about data net and how you can use the data net and even parse the data net for different information. So that's what we're going to be doing next. Let's go.